All right, so for this one, okay, just like before, right? What we want to do is we want to get two different points on the line, okay? Two different points on the line, okay? Let's do that. So from here, but again, just like before, I chose x to be 0, right? And then what I did was, once I replaced x to be 0 in the equation, right? The x part is gone. We get 2y equals 4. And that's actually pretty simple, right? Why is that simple? Because then you can divide both sides by 2, right? Because we want to get y, we get y's 2. So in other words, we get 0, 2 is on the line. Okay? 0, 2 is on the line. For this one here, we need another point on the line. So I'm choosing y to be 0. If you chose something different, that's okay. You could choose a different x value. You could choose something besides 0 for y. As long as you get two different points on the line, that's what matters. So I guess really the direction should have been find two different points on the graph of this. Not really so much sketch the graph, but anyway, we get 7x plus 2 times 0 is 4. Right, when y is 0, so this part's gone, we're left with this. Okay, so from here, we get 7x is 4. So what do? We want x, not 7x, so we divide by 7, both sides. Doing so, what we get is x equals 4 over 7. 4 over 7. And so from here, we get this point is on the line, right? When y is 0, we found x has to be 4 over 7. So because of that, this is on the line. Notice also that if we go from this point to this point, like say, for instance, if I asked you to calculate the slope, right? You would be able to see that from here to here, your x coordinate is going up, but the y coordinate goes down. Because of that, the slope would be negative, and the line should point down to the right, or should be falling, in other words. And that's what's happening here. So again, I know it does the decimal, decimal, it writes the coordinates in decimal form, not fraction, but hopefully you still get the idea. All right. Okay, that's actually it for this section. Not done teaching yet today. Oh, someone had a question? For the Lumen Learning, do you get the answers do you give your answer as an interval? For the homework? Let me look after class and I'll get back to you, okay? So I'll get back to you guys about that with the homework. Okay. All right. Are there any questions about this though? Okay, so let me start the next stuff then. I'll start 2.4 then. Okay. All right. So this is going to be 2.4. Now this is probably, again, this section is not easy, an easy section. Okay, I'm not trying to scare anyone. I'm not saying you can't handle it. Okay, I'm just letting you know that this section is kind of tricky. Okay, that's just how it is. That's just how this is. Of course, math in general is not an easy subject. I know. Growing up, I definitely struggled with math. It did not come easy to me. Okay. So Let's do functions now. So basically in this section, we're going to see what functions are. I mean, functions is really one of the most important topics we're going to cover in this class. Okay? Functions come up constantly in other math classes and in science classes. You know, functions are very important. I mean, if you go on to other math classes, you're going to study functions a lot more than we're going to do here. And functions, you'll see, can actually come up in many different ways. I mean, I tried teaching it class more by the textbook, but people had trouble. So what I'm doing is I'm presenting functions in different contexts. And from what I have found, students tend to understand that better. So we'll see how functions come up through what are called relations. We're actually going to see how functions come up with correspondence diagrams. Those are fun to draw. And we will see how functions come about through equations and graphs. And these are actually all connected to each other, as you'll see. They are all actually related to each other. And then I'm going to present what's called the vertical line test. And that's actually used to see with, well, you'll see what I mean. You might have seen it before. If you haven't, that's okay. All right. Now, this is really more of a reminder of what a set is. You know, the book goes a lot more into set theory, more than I think it should. Not to say you can't handle it, but I just think for Math 104, it does a lot more set theory than I think it should. But a set is just a collection of objects. That's all. Now, when you see the word set, you want to think, oh, collection, or group of if you want. Now, notationally, there are different ways of writing out a set. What I'm using here is these curly braces. Then I actually use what's called the roster form, where I list each element of the set. Basically, again, I list the elements one at a time between the curly braces. We don't list an element more than once, though. You may have to write a set out in class, and there's no repetition in a set. And the elements are separated by commas. I think that's okay. That's what we do here. All right, let me give you the definition of a function. So what is a function? Well, suppose you have these two sets here, capital X and capital Y. And usually people denote sets by capital letters. And this circle here is denoting the first set, capital X. This is denoting the second set, capital Y. A function, little f here is the function, from a set, capital X, to a set, capital Y. It's a rule that assigns to each element X from the first set, capital X. It assigns each element to only one element, or exactly one element from the second set. That's what it's actually doing. So you can think of a function as a rule that's taking each element from the first set, capital X, and it assigns it to only one element from the second set. It's assigning it to only one element from the second set. Theoretically, X and Y could be sets of anything. But for us, they're going to be sets of numbers. And really, to have a function, you have to have some kind of rule that fits this definition. You think of this definition as almost like, how do I say it? I guess a template, if you want. And if something you have fits the template, then it's a function. And we're going to see that we'll see that graphs and equations in X and Y, from those you can get a function. And graphs in the Cartesian plane as well. Okay. Now the first set here, as you can see, we call it the domain of the function. And everything in y that is assigned something is called the range. The way I like to think of functions is this. You could think of a function as almost like a machine. With a machine, right, you have input going in, and the machine does some weird stuff in the background, or like, you don't see what's going on in the background, so to say. And then the function for each input, x, the machine is giving you back only one output. So x is going into the machine is doing some crazy stuff in the background, and after all that's done, it gives you back the output. That's actually, you could think of it that way. I like to think of the domain as all the inputs and the range, everything that comes out of the function as an output. We actually have here a correspondence diagram. You have two circles, one for each set. You have the function being defined using these like arrows. For instance, let's suppose the first set here, okay, was just these numbers. Just these numbers, 1, 2, 3, and 4. Notice we have the curly braces and we have commas, right, to separate the elements when listing them, excuse me. This is our second set, capital Y. And then we can easily make a function here. Namely, with a function, what I'm going to do is say this. I'm going to say the function is taking 1 and assigning it to 2. So 1 comes from the first set, capital X, our input, right? And when 1 goes into the function, what comes out is 2, the output. 1 goes in, out comes 2. When 2 from here, from X, goes into the function, right? Out comes 4. 2 goes in, 4 comes out. 2 is input, 4 is the output. Same thing with 3. 3 goes in, 6 comes out. 4 goes in, 8 goes out. This is our domain. In this case, all of y is the range. That doesn't actually have to be the case. I could say here y is the collection of all real numbers, but this alone would be the output. And really what's making this work is for each input, right, you only have one output. So for 1, we only get one output, 2. When 2 goes in, we only have one output, 4. Oh, excuse me. And so on. Sorry, I pressed the wrong key. When 3 goes in, 6 comes out. So when you put in 3, you're not having 6 and something else coming out. That's why it's a function. All right, we have to stop. I'm running out of time. Okay. This one's so again, that's what's happening with a function. I know it's probably a little strange. I understand that, but we will see more of it.